I appreciate everybody having me, first of all, and taking some time out of your day to listen in. I'm going to be talking a little bit about the overview of Simplify batteries, as well as some specific targeted power bank training, since I know you guys have purchased a few of those units. So let's go ahead and get started. So just to kind of do a quick overview, and I think maybe even Dan might have covered this on the original training, just battery chemistry 101, talking about different types of storage. We've got our traditional lead acid batteries, definitely kind of a prominent battery for a very long time. Some other stranger chemistries, maybe flow redox batteries, even the Aqueon for a while, which is no longer in production. And then we've got our lithium batteries. Now, within the lithium umbrella, there's so many different types of chemistries, and it's important to differentiate the chemistries to understand things like safety and longevity. And I actually added a few slides in, so I know I had sent Calvin the slides I had, but I will send the updated slides with these ones as well. So this is a handy chart that I use a lot. These are all different lithium chemistries, and you can kind of see the side-by-side comparison. I won't bore you too much with everything here, but the main things to look at absolutely are cycle life versus depth of discharge, and then toxicity and thermal runaway. So as you can see, lithium iron phosphate really is the only lithium chemistry not prone to thermal runaway, which does give us a big leg up as far as safety and not having to use cooling and ventilation, things like that. So as I mentioned, there's a bunch of different lithium chemistries here, and within those lithium chemistries, we also have different form factors used to build these battery packs. So just to kind of go through these main three ones, the pouch cell, very common in laptops, even cell phones. These ones tend to be used a lot for polymer batteries, as well as some iron phosphate as well. These tend to swell a little bit, so they're a little bit harder to work with in storage, something we're looking for long term. Prismatic cells, that's kind of a hard case. This is this one right here on the right. These ones are a little harder to work with because they're hard to get in this tight spaces, because they kind of work as building blocks. Beyond that, they can also swell and tend to have less life cycles compared to the cylindrical cell. So the cylindrical cell tends to be the easiest to work with as far as space goes. It will leave a little space in between the cells, but they're very small, easy to wire, and have built-in protection into the actual battery. So it cannot short circuit, which is nice. So what do we use? Simplify batteries. Well, LFP chemistry, so lithium iron phosphate, partly I would say, almost entirely due to, first of all, safety and then life cycles, and then the cylindrical form factor. We've tried all three of these form factors throughout the time we've been in business, and cylindrical has definitely been the number one winner here as far as performance goes with batteries. So just a little bit about life cycles and what Simplify is warrantying. So your depth of discharge is your main factor with warranted battery. At 10 years, we do 10 years across the board, but at 80% depth of discharge, you have 10,000 cycles warranted. At 90%, we do 5,000 cycles warranted. And at 100%, we do 3,500 cycles warranted. It's important when you're looking at battery comparisons and things like that to not just look at what may be claimed by a battery manufacturer, but what is actually warranted, which can be kind of difficult sometimes. It takes a lot of digging and going through manuals and warranties. End of life is a term you'll hear a lot in warranties as well, which is what we define at that 10,000 cycles, what we would see EOL, or end of life capacity. We warranty for 80% EOL. That's pretty high. You'll see most companies are 60% EOL, especially on your manganese cobalt, and then you might see 70% on some other lithium iron phosphate. Great advantage of lithium iron phosphate as well, the wide temperature window. So not just operating, but also charging. We're talking -4 degrees Fahrenheit to 140 degrees Fahrenheit. And I apologize, I have this for our American distributors. I'm not sure exactly what it is in Celsius. But the great part about this, no need for coolant, liquid coolant systems, no need for HVAC cooling systems, and no need for ventilation. And we've used these a lot. This is to our advantage. So we've done a lot of work with the Department of Defense here in the States, where they are using these batteries in non-ventilated boxes overseas in very hot climates, getting right to this 120 degrees Fahrenheit for charging and discharging. So it's definitely been proven, and you really don't lose a lot of efficiency along this spectrum. Each of our lithium iron phosphate batteries does come with an integrated battery management system and breaker. This is built into each individual battery, and the breaker kind of acts as a off-on switch for that, as well as the battery itself. So this battery management system does a few things here. Short circuit protection, overcurrent protection, charge and discharge protection, and then the passive cell balancing. So important to kind of think about here, all lithium batteries tend to need a bit of balancing. Our batteries are great because we have BMS built into each single one, and they can work independently, whereas some BMSs need to be connected from one battery management system to another. You do not need to do that in this case. It works independently within its own battery pack. So just a little bit on battery sizing. I'm sure this is review, but I just like to throw it in real quick. Traditionally, we might have looked at 50% depth of discharge with the lead acid battery, definitely a norm, if not even 30% depth of discharge. Whereas with the lithium battery, we can use 100% of the depth of discharge. So we can use all of the capacity within the battery. Typically, we don't use 100%, and I'll kind of explain why in a second. But there are, as I mentioned, specific warranty parameters within those depths of discharge. So the variation in depth of discharge I tend to use is based off of the mode of operation. So if you're using something like battery backup, that might be a great opportunity to use 90% depth of discharge. So if we take a step back, we might see that 5,000 cycles are warranted at 90% depth of discharge. Well, if it's a backup battery, it's likely that this battery will not be discharged very often. So in that case, it might be okay to use 90 or 100%. And stick within that warranty within those 10 years because you're not using that many cycles. Off-grid, daily discharge, maybe 1 or 2 cycles a day sometimes even, that's where it's really important to use 80% depth of discharge. Things like peak demand, we might push that again to 90 or even 100% depth of discharge. And then let's say a net zero home where it's daily discharge, we want to use 80% depth of discharge. So it really does depend on your mode of operation. Picking kind of what depth of discharge you want to use and really examining what kind of cycle life you're looking to get out of the battery versus the way that the customer may be using the battery. So just to kind of pull out one of our spec sheets here, and this is actually for the 3.5 model, and the 2.7, which is what's in the power bank, is a bit different, but virtually they're going to be very close to the same, just the difference in capacity. So you know, you got your things like, and this is all of our spec sheets are kind of standard across the board. That's why I like to go through it real quick. DC voltage for the 24 and the 48, your amp hour rating, and then your capacity by putting these two together. Max discharge current, I get this question a lot. So this is the 10-minute max discharge at 60 amps. Now, it can definitely do a lot more at the smaller numbers, and I can make that data available after the presentation. We've got some more maybe 10-second rates and things like that for surge and well pumps and you name it. So max continuous discharge and charge is C/2 rate. So these directly correlate with that. So you can 45 amps max charge and discharge on the 24 volt is a little bit less than C/2, but that's what we found to be the best for that specific 24 volt. and then 34 amps is exactly C over 2 for the 48 volt. DC voltage range, this just refers to the top end and the low end of the battery. Lithium iron phosphate tends to have a very narrow voltage range as well as a very flat charge and discharge curve. So you might see that with a lead acid or something, you might have an installer say, hey, it's really, you know, I'm used to going all the way from one end to the other, you know, maybe it's 20 volts or something along those lines, and then they might be a little bit deterred or taken off by this, but it really is those flat charge and discharge curves that even 0.2 of a volt makes quite a difference within these batteries. Some other things to consider here: depth of discharge, as I mentioned, up to 100%, but you'll see down here 80% is recommended for 10,000 cycles. Operating efficiency, 98%, very high. Operating temp and charge temp, we already went over. Memory effect, this was more pertaining to lead acid replacements, as it's a kind of an important factor when looking at replacing a lead acid battery. And then just warranty period and the weight of the battery. I believe the 2.7, which is what's in the power bank, is closer to about 55 pounds. So the power bank. I wanted to throw this in there and kind of go a little bit more into detail on this product, since I know those are what were purchased. So the kind of quick overview: first, the staple of the entire unit, two 2.7 kilowatt hour 24 volt lithium iron phosphate simplified batteries for a total of 5.4 kilowatt hours of total energy storage. It also comes with a Magnum Energy MM1524 AE 24 volt inverter charger. And that's actually built in, and you'll see a picture here in a little bit where you can see where everything's kind of laid out. So within that inverter, you've got 115 VAC, 15 amps AC output, and you've got 100 to 120 VAC, 20 amps AC input. You also have the ability to pair with 1,000 watts of DC input. Typically, that's going to be solar or wind, but the connection is up to you as far as that 1,000 watts of DC. So some use cases for the power bank, at least from what we've seen. This is definitely not all of them, but the kind of the big ones here. Portable power, huge one, bringing on site. Standalone / off-grid. Not as big, but definitely also, I mean, in the sense that it's always off-grid, but maybe not relying on it as your sole housing source or something along those lines. UPS, uninterrupted power supply, definitely one of the biggest ones. And then backup power and grid down. This is actually great. So this is a great little use for this when looking at somebody that maybe just wants to not even go with solar or wind, they just want power to be backed up when the grid goes down. Well, instead of costing yourself the expense of putting in a critical loads panel and throwing in all this expensive equipment, this is kind of the all-in-one quick. They can roll it, charge it up, roll it in when the grid goes down, and power things up. I've also seen these a lot in hospitals down in South America. I believe we did some big projects with these for some kind of critical needs stuff as far as power goes. So some standard features that come with these units: you have 4 AC outlets, and these are all ground fault protected. You have 1 AC inlet. Now this is mostly for the grid pass-through and the battery charging. You have 2 USB outlets, also for charging USB devices. The user interface is this unit right here, which is the Magnum ARC50. From this unit, you can change settings. You can see the voltage of the battery. You can see amps out, amps in. You can do all sorts of things with this unit. You can even turn off and on the unit from here without turning off the battery. So as I mentioned, there is the DC power inlet. So we kind of leave it up to you for what kind of adapter. If you want some kind of MC4 or maybe something else going into that, you would use that DC inlet to run that DC power. Storage and cabinet, obviously, and that door does lock, so you can store things in there. And then just the workspace on top, so that the idea here is that this unit takes up as little wasted space as possible, so that it can go into maybe a garage or anything like that and still be utilized as a workspace as well. So as far as installation, and this is even just receiving as well, it's important to inspect the batteries, inspect the parts, make sure everything's there. There is a whole list of materials in the manual that should be there. So it's really easy just to run through it real quick, make sure. Once that's done, the 80 amp circuit breakers, you can see here, I got my mouse over it. These are the off and on switch for the battery management system as mentioned. So this will turn off and on the system. These will come off. So you need to turn it on. Not a bad idea just to check the polarity real quick and make sure everything's wired up right before turning on. Then from there, the inverter will light up, but you have to turn inverting on from the ARC50. Then you're ready for use. The only thing beyond that is batteries cannot ship at high state of charge, so we will typically discharge the batteries to about 30% state of charge before shipping. So you will need to plug in and charge up right when you get the unit. And then within the manual, and I'll get into where to find this product documentation, there is some specific use case type installation methods. So as I mentioned, let's go back a little bit. These are definitely in it. I think there's a couple more even where it tells you exactly the method of how you would hook up for these different use cases. And that can be pretty helpful for sending out to installers or even end customers. So product documentation, if you go to our website and go to support, the support tab, you will find all the product documentation there, where you'll find also the power bank installation manual. You can also just go to the product itself on the website to find this documentation. And I can send out the full installation manual as a PDF after the presentation as well. Troubleshooting help. This actually comes straight out of the manual, and this is super helpful for troubleshooting. If you see one of the symptom here, the possible cause and the solution. So these are kind of easy fixes where maybe there's nothing actually wrong with it. It's just doing what it's supposed to do and going into a certain state of protection. So this is kind of a quick guide table to get a problem solved quick. Obviously, if that goes beyond that, always feel free to contact our tech support either by phone or at techsupport@simplifiedpower.com. We're always more than happy to answer questions, walk through any kind of troubleshooting, or even just help us with pre-sales stuff. So the warranty, I kind of talked a little bit on it, but I wanted to go a little bit more into detail. So each warranty level kind of correlates with certain set points. So you might see here the 10,000 cycle warranty. Well, the charge and discharge rate's the same across the board, but the depth of discharge is different. Operating temperature, same across the board. And then these are a little bit different, and it'll come pre-programmed for that 80% depth of discharge. However, we can kind of adjust things as we want. So this voltage directly correlates with depth of discharge here. So 24.8 being 90%, 24 volts even is 100% depth of discharge, as well as the high end also correlates a little bit with the cycle life warranted. And just to kind of reiterate on this, please feel free to reach out to our tech support if you have anyone that has questions on the programming of this unit or any simplified battery that's hooked up to an inverter. Even if it's not something all-in-one, we're more than happy to help walk through how to program our specific settings into those different inverter and chargers. So if for some reason you are looking to obtain warranty service, the RMA form, return merchandise authorization form, I'll make available if ever need be. And our tech support also is able to do this. Super easy. Typically we have the distributor installer work with the customer to make sure all the information is correct. I won't bore you too much with this stuff, but so you know, if it is ever a warranty claim and it's accepted, we send a new unit out before we receive the old unit to kind of ease the process, especially on customers, or if it's off grid or critical power, we want to make sure we get out a new unit as soon as possible. And then we run our root cause analysis on the unit to determine what the cause of the failure was. It's pretty rare, especially, I don't think I've ever seen a power bank come back, but sometimes units, batteries will come back. It's pretty rare though. Some of the required documents would be a super basic single line drawing just to see where things are coming from, purchase agreement, pictures of the installation, and some battery field tests. So I want to talk a little bit about installation. I know, we kind of were focusing on the power bank there, but I wanted to get into installation in regards to our 2.7 and 3.5 kilowatt hour batteries. So just some basics, and this is for all Simplify products here. Check the batteries for damage always. Definitely check the breakers, make sure they can hold in the off and on position. Take a multimeter to the battery leads with it on. You should expect to see something between about 50 volts and 53 volts. If it's something off like that, just give our tech support a call right away. Let us know, and we can make sure that it's not an issue. As far as shipping claims, really important that we don't take responsibility after it's left, so it is on the receiving party to file that shipping claim right away. So it's definitely important to file it, then contact us, and we can work together with our shipping department to make sure that everything gets sorted out. Safety, I don't need to really harp on this too much. Obviously, breaker use is great. I love that our battery has a breaker. It makes installation super safe and easy. Insulated tools, eyewear, multimeters, just great around for everything, whether it's troubleshooting or just the initial commissioning. And then obviously checking the battery polarity, super important before plugging anything in. So these are our 2.7s. And these units are, this is kind of a little bit about mounting. Now these are using our Simplify bracket. We actually sell these brackets specifically for our batteries. That being said, you don't need to use our specific brackets by any means. We're pretty liberal about how you orient the battery, what you put the battery in, because really there's no heating requirements. There's beyond the very wide temperature range. There's really no cooling requirements either, again, beyond that temperature range. The only orientation the batteries really cannot sit is with these battery leads upside down. But they can sit sideways. You can turn them on their sides. It doesn't really matter too much where they are. There's really no clearance requirements as long as these terminals are not close to these terminals. And you can also use battery box and racking systems. All sorts of different orientations here. And something I just want to add real quick, since I know it's not in the slides later. Great part about our batteries, this specific installation started out with half of these batteries. And later on, they came back, and I believe it was about 2 years later, maybe even 3, and installed the next set of 2.7s. So you can come back and install new batteries later. We do not. I know a lot of lithium battery manufacturers say you need to get everything right out of the box. You can't mix old with new, but we definitely can, and we have quite often. So a little bit about our wiring techniques. We do it a little bit different than you might see with traditional lead acid batteries, where the traditional would be to go from positive to next positive, to next positive, next positive, up to whatever you are connecting to. We try to make sure that everything can balance out correctly, as well as it kind of plays nicely with the battery management system. So what we actually use is, we recommend going from positive to common bus. So each positive goes to this common bus, each negative goes to the common bus, and then this would go out to your inverter or charger, whatever you are hooking up to. This can be accomplished a few ways. If you're using something like a Schneider, Outback, SMA, any of the big inverters, and you're using their power panel, you can connect. They typically have a copper bus that you can connect to. I think for the most part, those can fit about 3 or 4 batteries. But now if we're going with these bigger systems, like you see here, you can see they're using some DC buses here to actually connect all the positives. and then to connect all the negatives, and then just have one run from here. So it really does help distribute power evenly, as well as keep the batteries just nice and in balance when they're discharging as well. I get this question quite a bit. As far as torque specifications go, you definitely want to, first of all, I get the question quite often, should I use a proper torque wrench? Absolutely. It helps over and over again. It's going to help. You don't need the most expensive one, but definitely want a torque wrench. 160 inch-pounds and 13.3 foot-pounds. Again, apologize for the metrics here. I believe the conversions are in the installation manual. Over torquing the battery will damage the battery. So if you go way over the top, you definitely can. It takes quite a bit of pressure to hurt the battery leads, but I have seen it done before. As well as when you're not torquing to these specifications, you might see some issues with the power in and out of what you would actually expect. So other simplified products beyond what we kind of talked about, these we already talked about, but I like to go through them. So these really are the staple batteries of everything we do. The 2.7, 105 amp hours at 24 volts, 52 amp hours at 48 volts, and then even more popular, the 3.5 kilowatt hour battery. This is 138 amp hours at 24 volts and 69 amp hours at 48 volts. So really what we strive when we built these batteries, first of all, is the easiest possible drop-in lead acid replacement. We want to make it as simple on installers as possible. No RS-485 connections from the BMS, no complicated wiring, just super simple. Drop in, reprogram, and you're good to go with a new lithium battery where lead acid may have been. And scalability is the second one. So as I mentioned, you can add batteries later, as well as with the paralleling connections, there really is no limit to what kind of sizes we go up to. Obviously, if you're going to go over like 300 kilowatt hours, it might be smarter to look into our high voltage product at that point. Those are kind of microgrid size systems. So integrated battery management system, I already mentioned that. Each unit has one. The breaker's here for this one, and the breaker's on top for that one. And that breaker also is a next level of protection as well. The access unit, this is a fairly popular one as well. This unit's about 6 feet high here. This is a NEMA 3R enclosure, so this can sit outside. Does not require heating or cooling. Battery range from about 7 to 14 kilowatt hours, but we are expandable with these units, so you can actually add more energy, or you can add a full parallel unit. Warranty is the same as all of our products. These are great for AC coupled systems, existing PV. The unit itself actually comes with either a Schneider XW Plus or an Outback Radian here, and then the batteries are in the bottom. So it also has the option for an optional charge controller if you're going to go DC coupled as well. So tons of different applications for these units. One of the biggest benefits being that they are outdoor ready. So if you've got an installation site that's tough, we don't want to work inside, these are great for just a quick, easy outdoor installation. Really not a lot the installer needs to do. They come pre-programmed, pre-wired. All you're doing is knocking out some conduits and running some PV in and some AC output to your loads panel. So I won't harp on this one too much, but this is definitely a pretty popular unit, and we do have a smaller version of this hopefully coming out here pretty soon. We also have our kind of what we were founded on was the Liberty Pack stuff. So this is all portable power. It kind of ties as well into the power bank here. So we've got our little Jenny, our big Jenny, which can also have the solar panels, and then our power belt. Traditionally, we use these for the film industry here in the United States. And from there, we kind of moved on to disaster relief and emergency power as well. So these are all using the LFP chemistry. We still stick with our same cells, same everything, same chemistry, and same standard of batteries. So this is kind of sales related, but I wanted to throw it in real quick in case it hasn't been covered yet. I get this a lot, especially on our pre-sales line, as far as installers trying to sell the system and really trying to get an idea of how to compare different batteries. So I use the levelized cost of energy. So the equation is super simple. It's just the MSRP of the battery divided by the total capacity times the cycles warranted, not just the cycles claimed, times efficiency, and times the desired depth of discharge, plus maybe some ancillary costs depending on your battery. What this gives you is really exactly what it says, a levelized cost of energy. So when we run these cost analysis, we might see that even though the LG Chem or maybe the Powerwall are cheaper up front, over time using this formula, we can see that the benefits of going with an LFP battery and going with our battery specifically. Some things on ancillary costs, this might include things like the weight, the shipping costs. Do you need a forklift? Do you need a ton of square footage? Are we building a whole new structure just for the unit? Or is there cooling requirements? These can all play in, and these are kind of on a case-by-case basis to use those ancillary costs. Then I want to go through just a few applications that I like to talk about. So this one is grid-tied backup power, huge backup power, obviously. 10 kilowatt array, quite a bit of batteries. You can see here that they're using a midnight combiner with an Outback Radian and some FM80 charge controllers paired with our batteries. The batteries are kind of hidden here in the back. This one was kind of our spotlight. This was off-grid power with the governor of California. You can see here where we have 9 batteries, 3.5 kilowatt hour batteries, some Radian 8000s, and then all nicely wired up into these combiners. Grid-tied car charging, I actually get this quite often. Can I charge my car when I get home, harvest all my PV, and then discharge into my car when I get home? As well as this specific one was interesting because they were the only one in the neighborhood to maintain power during one of our NFL Super Bowls. So everyone probably came over to their house. Some bigger systems here, as I mentioned. So with these 3.5s, when we're paralleling the units, this is about as big as we want to go with the 48 volt model or 24 volt model. But this is the 300 kilowatt hours, 88 batteries, all in parallel. You can see the combiner boxes here. Here's one again. So there's 1, 2, 3, 4, 5 combiner boxes. And some, I believe these are the Magnum 100 amp charge controllers. And you can run through different parallel connections here. So definitely scalable is kind of the point to drive here. And due to the modularity of the battery, since each one does have a battery management system, there's no special requirements here. It's simple. All you're doing is connecting positives and connecting negatives, and the system will do the rest. Again, I guess I keep harping on it, but scalability. I also like this one because it shows how some different methods of wiring. You can actually use the bus bar here. And since that's distributed evenly, they just have connections coming off of here. Fairly large system as well in this hangar. You can see all the batteries connected via bus bar here and then running out to the different various systems. Diesel replacement or diesel offset's a big one we've done. That was actually our biggest one with the military contract, was cutting down on diesel use. And it doesn't seem like it's going to be a lot, but we found it to be 50 to 80% diesel offset using lithium iron phosphate batteries. What I mean by that is, think about when you have a diesel generator that's running a microgrid, maybe a small microgrid, such as the military forward operating bases. Well, they're running the diesel generator constantly, but they're not using all of the power being produced all the time. So by storing that energy, we cut down quite significantly on the actual runtime of the diesel genset, and we can store the battery power and then actually use that battery power when needed and not run the generator all the time. Awesome. So I'd love to open it up to some questions. I don't know how much time we have here, but I would love to um, get you guys off mute here and then just go ahead and get some questions down before we run out of time. So let me, okay, I think you guys got to unmute yourself here. There we go.
Yeah, thanks, Troy, for the training. Any questions from our side? Troy, just double confirm with you. You mentioned you will record this training and send us the link to access to it, right?
Yep, I've got the training recorded and I will send you the updated PDF version since I did send you the one before I did some editing, so.
Yeah, sounds great. Yeah, just one question from JM.
Hey, Troy, thanks for that. Just in regards to the performance of the battery at lower temperatures, have you come across like a real slowdown towards the 0 degrees Celsius or 32 Fahrenheit mark?
Sure. So really with the colder temperatures, really with any of the temperature window, we do see a little leeway between maybe a couple percentage, not like a lead acid where you're going to see significantly different efficiencies at lower temperatures versus higher temperatures. Now that being said, if we are reaching that bottom end, it is a bit advantageous to maybe if you probably don't want to operate at a C over 2 rate at the very lowest end or the very highest end. You kind of want to limit the charge and discharge in order to make sure you're maximizing efficiency. So to answer your question, I would say if you're operating at C over 2 at that lower temperature, maybe within a 5-degree, 10-degree window at that low temperature, you will see lower efficiency than you would if you were to be at a higher temperature. But quick fix, again, just make sure that the charge and discharge rate's a little bit less than C over 2. So maybe C over 5 would be great for those kind of temperature extremes. That being said, though, I would like to say also with the Department of Defense, they were using at about 120 degrees Fahrenheit, the batteries at C over 2. So whether they probably didn't run the efficiency rate on that. I wish I did have that data, but I can say it's been operating for about 9 years now, and they've seen 0 failures out of that battery. Out of those batteries, there's quite a bit of them out there.
And just as a follow-up, do you have, for applications of off-grid in particular, because there's a lot of homes here that are off-grid and little islands and whatnot that would be able to use this technology really effectively. Is there a heating type product that you would recommend to ensure that you kept that mark in the wintertime, especially?
Yeah, there's a few things you can do. So the biggest one here is say you're operating on a system and maybe your system's in a utility room. Well, if it's operating with like a Schneider or an Outback or a Magnum or whatever the inverter is, those guys tend to run super hot. So as long as you are using energy and using power, the inverter tends to be enough to actually keep the batteries warm. And we also have to consider the ambient temperature might be one thing, but the battery inside of the battery is going to be a lot warmer than the ambient temperature. There's insulation in between it, as well as the cells run a little bit warm. So it's when we get to the very extreme. So I definitely have done a lot of work in Alaska where, and obviously that would kind of pertain to this case if we were to go way up north, but it really is all about operating more than anything. So if you're not operating, that's when it's going to become an issue because the whole system kind of goes cold. Great solution there would be some kind of heating pad. They do make some thermal heating pads. They're very inexpensive. And not to get too kind of over the top here, but what I've done in the past is you hook up the heating pad maybe to some kind of thermostat that would be hooked up to a relay to come on at certain temperatures. That way you avoid wasting excess power and keeping the batteries warm when they don't need to be. You could also get that accomplished with just a basic space heater that, again, hooked up to a relay, comes on at a certain temperature, and then turns off at a certain temperature.
Thanks. Yeah, Troy, just follow up the question from JM. In your battery, there's integrated BMS systems. There's kind of the preconditioning mechanism just to warm up the battery in the winter system. Is there any likely mechanism integrated? Or
So
we
with
have the external devices just to pre-warm the battery.
Yeah, so the BMS really doesn't do too much as far as pre-warming or anything like that. Really what it does is temperature protection. So let's say you were to hit that low, and maybe the heater didn't turn on or something along those lines. If it did get to that extreme, the BMS would shut down the battery and go into an open circuit. Now, that's a lot lower than what we actually recommend. So the idea is we don't want any nuisance tripping, as that can happen quite a bit with lithium batteries and battery management systems. So really all it's doing is it's there to protect the extremes, but it's not there to regulate, or it's there to regulate the cells as far as the high end mostly, but really not on the colder end of things. And since we're not prone to thermal runaway, it's really not performing that much of a heating and cooling function as you might see with some other batteries that are maybe cobalt based batteries that really do need that cooling and heating system built into them.
Yeah, just in case, just to avoid the thermal runaway, right?
Exactly.
Hey, Troy, on the sales point of view, would you have some competitive information on LG and on Tesla compared to your product?
Yeah, and I can send those. Let me take a note right now. I'll send those over. I do not have the newest Tesla one built up. I do have LG though, and it's a side-by-side comparison using those LCOEs that I can send you. It also is a bit kind of wordy, so it goes a few paragraphs into the differences and kind of extrapolating different warranties. So I'll send that over after the presentation. And then if you have any suggestions as far as if you're saying, hey, I'm really seeing a lot of, Discover battery or BYD or whatever it is, let us know, let Dan know, or let myself know, and we can always talk about getting a comparison built up for you.
Right. Sure. I think later this week we will have a marketing kickoff meeting hosted by Simplify and Brian. We will talk about our requirements for the materials.
Awesome.
Trey, still I have some questions. We already purchased several products from Simplify, and they are already in front of us. 2 power bank and 1 Simplify 3.5 kilowatts battery modules. But we haven't started to use it. Do you have any suggestion to do the initial check and like the SOC value, the initial voltage values?
Yeah, so definitely take a multimeter to the batteries. As I mentioned, you should see somewhere between 50 volts, or I'm sorry, those are 24-volt batteries. So you should see somewhere between 24 and I'll say 26. You're really not going to see higher than that out of the gate. And then for the 48-volt, if you do have one of those, you should see between 50 and 54. Now, if it is irregular for any reason, just let us know. I mean, if you really want to test the unit out, also you could possibly turn off the power and plug in some laptops or whatever to the power bank and see about using energy out of the unit. But other than that, really just check the voltage. That's the biggest system health indicator that I would say. Beyond that, there's really not much else that needs to be done with those batteries. They're fairly simple and don't require, BMS programming or anything like that.
What is the initial SOC status before you shipped out from your warehouse?
So I'll be honest, it's supposed to be 30%. We did hire quite a bit new manufacturing this year. So I have seen some going out a little bit higher, maybe somewhere between 50 and 80%, but standard you should see is 30% SOC anytime it ships. And now the battery does not lose SOC very easily, so the self-discharge rate's very low. So really, if it sits in a warehouse or even sits in a customer's house, they're not going to see a difference, and the battery's not going to discharge itself unless they left it for multiple years.
Yeah, and also there are several user manuals with the packing, like the user manual for the battery, user manual for the inverter, even the remote controller. So later on, you're expecting the end user to read them first before they really start to use the battery product.
Yeah. And then while on that subject, since we have a quick second here, I'd love to show this real quick. Can everybody see my screen?
Yep.
Okay. So on our website, so this is kind of my domain here, being kind of the support and training. Is under support, you're going to find product documentation. So this goes well beyond just spec sheets, warranties, and the basic installation manuals. This also goes into integration guides, which are super helpful. So say you have somebody using maybe an Outback Power, charger and inverter. Well, we can pull this guide straight out of our website. And then this specifically goes into the inverter settings that pertain to that particular inverter and the charger settings pertaining to that particular charge controller. So there's really no question at that point. And if you ever see one that maybe, if we're missing one that you want to see, just let us know. I definitely try to keep up on these, but it can be hard to keep updating them over and over again. But these tend to be really useful with installers because each inverter and each different power electronics company tends to have a bit of their own language, as well as settings that are allowable. So this kind of takes the guesswork out of it.
Actually, we are also developing our own off-grid or hybrid solar systems. Would you suggest we starting with the power bank as the battery or the 3.5 kilowatt battery module, battery cell to do the system integration?
They'll really leave that up to you. I mean, as far as using the power bank for off-grid, it's going to be a lot easier as the programming's pretty much all set up and ready to go and all the connections. Definitely not a bad idea to start getting familiar with how the 3.5s interact with these inverters and different chargers and kind of do a from start to finish installation.
Yes, so for the power bank, the Magnum inverter is already integrated, right? Correct.
So I don't think this one has the best picture, but all of these are already hooked up, all your outputs, all your inputs. The settings are already in the Magnum and the Magnum's already in the unit. So really all that needs to be done is it needs to be turned on and connected to a power source. You're more than welcome to go into this ARC50, go through some settings, see what's actually programmed, see how it works and things like that. But really everything's pretty much good to go. And as I mentioned earlier, these are the mode of operations specific installations. So you might see, if it's a standalone or an off-grid, you can follow these specific instructions for that mode of operation. It kind of takes the guesswork out of it. So this is specific to the power bank.
Troy, one more question. Have you done any case studies in regards to replacing a diesel system with your products and the greenhouse gas savings that were incurred as a result?
I'm not 100% if we've got the specifics on the greenhouse gases. I know we did publish some papers regarding the diesel offset of the Department of Defense. A lot of that had to do with saving lives for the caravans bringing in diesel. I'm not sure. I would say probably bring that up though to our marketing team when that kickoff call happens, and they will know. They know all of the different pages and white papers and things like that we have.
Any more questions? Yeah, Troy, we think we are good here.
Perfect.
Thanks for your explanation.
No, and thank you everyone for joining. My email specifically is troyd@simplifypower.com. If you have any questions or any projects come up, feel free to reach out to me. I don't mind at all. I'm happy to answer any questions that come up. And then obviously, feel free to reach out to our tech support specifically for pre-sales questions. They are very educated in not just batteries, but the power electronics as well. So they can really help out with system sizing, integration, and things like that. So I really appreciate the time, and I'm looking forward to the partnership.